So what I want to talk about tonight is something that I basically call Java programming best practices. And then I got a little silly. I thought to myself, well, how would Yoda do it? Maybe code good in Java, how to? Or if I wanted to insult a bunch of people, I might call this presentation, it runs, gives the correct result, and you're all fired. I'll explain why shortly. Or finally, if we make fun of my age, we can describe this as the ramblings of a Java teacher who was a toddler at the dawn of COBOL. And I did make sure I was born 3 years after COBOL, not 3 years before. So you already know a little bit about me based on what's been discussed already, or what Mary was kind enough to say about me. I started in an unconventional manner. I was a graphic artist, I was a photographer, and then I became a computer developer. And there's a link at the bottom that will explain that jump. I had the good fortune of being invited to join the faculty at Dawson College. And in my over 30 years that I've been there, as you can see, I've been the chairperson of the department and the program coordinator. I'm also a part-time instructor, as Mary pointed out, at Concordia. And then simply because I'm an old person with grown children and nobody to look after, I decided to adopt different categories of activities. So I became a Java champion. Actually, they adopted me. I had the good fortune of being elected to the JCP executive. I decided to bring a little of the conferences I attended in San Francisco back to Montreal and started DOSCON, which is going for its 5th year. And then that little link down there that if you want to learn for some strange reason a little bit more about me. If you're wondering, the Omni Prof, before I became a teacher, I had a business called Omnibus. And so everything I do usually begins with the word Omni. And so if you go for Omni Prof on GitHub, GitLab, you'll find all my repositories on GitHub. You'll even find tonight's slides. Let's make this happy. There we go. So a little bit about, well, where my students come from, because they're, of course, the driving force behind my concepts of best practices. So Dawson College is an institution that sits, well, depending on your goal. If your goal is a degree in university, you come to Dawson College for 2 years. High school finishes in grade 11. You come to Dawson for effectively grades 12 and 13, but in an environment that is akin to a university. So if you were to walk into Dawson College, you'd probably think you were in a university, certainly not a high school. But you come to Dawson for 2 years and then off to university. Or you come to Dawson for a career. If you want to be a nurse, if you want to be an X-ray technician, if you want to be a foreman on job sites for civil engineering, you come to Dawson College to be trained for 3 years. And in Quebec, computer science is a 3-year career. We take our students and we train them to be software developers. Our goal is to ensure that the day they walk out of Dawson, they are ready to go into any workplace and be productive. They understand the workplace, they understand the problems they have to solve, and they're ready to go. Frequently, when I meet new students or students thinking of us, they ask me, what do I need to know to get involved with software development? So a little, in a silly manner, I might say, can you tell the difference between a keyboard and a mouse? Thankfully, everybody does say yes, but actually it doesn't matter. We look for passionate students who want to be software developers. Now, they join us and they discover, well, wait a minute, maybe software development isn't my future. That's okay. There's 21 other careers that someone could take at Dawson College. Now, at the end of our program, I talk about the end of our program because I teach exclusively in the final year and I do the project courses. It's my goal, or it's my, the purpose for my courses is to take students who've taken 2 years of basic computer programming along with English, humanities, I've seen discussion about concern about ethics and training. Well, our students take 3 courses in ethics over the 3 years with us. My job is to take their basic knowledge and reshape it, remold it into something professional. And then when they finish with me in the winter semester, we put them out on an internship for 7 weeks. We arrange the internship. They are required to work as developers. They have to be a member of a team. They have to be contributing code to the company's projects. Most of our students are hired. About a third of our students go to university, but what they report back is everything they need to know, everything they've learned about programming, they've learned at the college level and not at the university level. So, what are we here for today? A topic I've called best practices. And certainly a topic that can be argumentative. Best practices are related to the particular tasks. One could argue that best practices in Jakarta EE are different from the best practices in Java SE. I'm trying to look at the more general. So let's think of it, and I always like to think of software as an engineering discipline. If an engineer is given the task of, say, building a new bridge, and from what I understand about infrastructure in North America, we need a lot of new bridges. But these engineers are not going to sit down and say, can I think of a new way for a bridge to stay up in the air? Can I invent something new? Well, there are probably some rare circumstances when they might have to. But the reality is an engineer will look and adapt proven patterns, proven approaches, proven technologies. I believe best practices in software work the same way, that we adapt proven patterns and technologies, but find unique and novel ways to employ them to solve our problems. So, what we're going to see now are the best practices that I require in some cases, or just hope my students will employ. So, best practice number 1, and there's no real special order here, so don't look for anything significant. Well, best practice number 1 is you need to read. One of the things that I've enjoyed about software, it's why I did it for 10 years and then had the opportunity to get into teaching and deal with it in a different manner, was the fact that I'm not doing the same thing every day. That every problem, in my case, in trying to figure out the best way to present information to students, I'm always learning something new. Oops. I'm hearing somebody in the background. Is there something I should hear? No? Okay, I'll continue. Okay. So, when I was a freelancer, before I got into teaching, and if you look at the years there, that's 1982 to 1991. I believe yesterday was the anniversary of the internet, which went public in 92. So, during that period of time, the only way to do research was to buy books. And I remember every time I had a contract, when I was working out, what am I going to charge for this particular task, there was always a minimum of $1,000 for books. I had an interesting approach to taking contracts in the 80s. It didn't matter what you asked me to do. I said yes to everything. We can talk about that another time, some interesting adventures doing that. I've always felt that every time I'm doing a project, every time I'm working on something, it's not a matter of what I've already learned, but I'm relearning all the time. So I believe one of the most important best practices is to be prepared to read, whether it's from books, and there's some great publishers out there now, whether it's on the internet. We will read probably far more than we write. The next best practice I've actually called, kind of strangely, practice. As part of what we learn. And, I think of something a student of mine once told me, and that was after they graduated and been in the industry for a few years. They described what they did on a daily basis as searching Google. And, well, I was hoping, they might actually still remember some stuff from our classes, but he had a point. We frequently find ourselves going out there, whether it's Stack Overflow or the thousands of blogs, even an ebook that you can extract code from easily. We're looking for solutions. The point I want to make here is we can't just copy and paste what we find. We have to test it. We have to practice using that code. We just cannot assume because it has a green check mark over at Stack Overflow that it's a simple cut and paste job and we can move on. Best practice number 3, refactoring. I'm going to begin with a little story, and you can see it broken down in the slide here. It's a story of a young developer who was teamed up with a luminary. So a luminary is somebody who, if I could remember this person's name, we would all know that person. It's like saying James Gosling. There's a perfect example of a luminary. Or Mary. There's another luminary. So this young developer writes in his blog that he was all excited. He was, teamed up with this luminary. And this luminary made one point clear. The program needed to fulfill the requirements. No worry about code quality. No clean code. No time for that. If they were lucky to finish a little early, well, maybe they can go back and clean it up. But the focus was make it work any possible way. Well, I kind of disagree with this approach, even though I do have great respect for these luminaries. My feeling is, and I hope yours is as well, that good code quality needs minimal refactoring. Poor code quality is resistant to factoring. So here's a little, maybe I should call it a skit. And sadly, when I mention this to people, I usually see far too many heads nodding. So you go to your manager, you go to your lead, and you go, that proof of concept code we needed to produce, it's working. It's giving us the right answers. To which your manager replies, great, push it up to QA, put it in the server, you're ready for your next task. Wait a minute, you reply. I've got to refactor the code now. If someone else is going to come in and maintain it, if someone other than me is going to work on it, I have to shape it in such a way that it can last. To which managers all too often will say the budget, the company policy, my own incompetence does not support refactoring code that works. At which point you go, not again. Code, clean coding, code quality begins with the first character you type. Yes, refactoring is important. You need to review. You need to consider who's going to be using your code. Which, of course, leads us to comments. If there's one area that gets me into trouble when I whine on Twitter or some other social media practice, it's my feelings about comments. So I start with this first basic idea. Imagine you're standing on a street corner, busy street corner, because you've got to have people walking by you for this experiment to work, and you pull out some source code and you proceed to read it out loud. Heck, get a megaphone so everyone could hear you. So the question is, as you're reading out loud your Java, your C#, your Rust, your Go, pick a language, would anybody who bothered to stop understand what you were doing, even though they know nothing about software? This is what I call self-documenting, and I think it's important. I really do believe that well-written code read out loud to strangers will mean something to them. But of course, we're not really writing code for these strangers. We're writing code for a company, code that should, generate revenue, that should last a good long time. And for that reason, self-documenting isn't enough. So as an example, why did you choose a particular algorithm? Talk about that. We once had an internship company that forbid its employees from writing comments. They really believed that self-documenting code was all they needed, right? If, that street corner test is passed, we're fine. Of course, what students reported back to me was that they wasted a lot of time trying to figure out what the company's code did, and actually what I consider more important, why it did it the way it did. So this is what I tell my students. You have to comment everywhere, right? There should be a comment block before each class, and I'm assuming you all know this, but maybe you get lazy at times. That block should tell us why the class exists, explains how you coded it. Does it employ any recognizable patterns? And what do you see as the best way to use your class? The comment block before each method is very similar. What's its purpose? How to use it? I also strongly believe that every single method, regardless of access control, public, private, protected, package, they all get commented the same way. Granted, the Java docs will only pick up the public methods. The fact is, you, the people you work with, the people who replace you are going to read your private methods. You need those comments there. Obviously, don't comment something that's, obvious. Frequently, I will see methods, especially in my students' code, where there is typically a numeric input. And so I go, there's got to be a range here. What's the range? And that I don't see. Maybe they have an if statement looking for a range. Even with that if statement, to me, that's an important piece of information that I need in my documentation. I don't need to search through the source code to discover what the minimum and maximum. I tell people you can never write too many comments, only too few. And if it troubles you to have all those comments, if they appear to be taking up too much space on your screen, most modern editors allow you to hide the comments, so you don't have to see them until you need to. I want to talk about a recent experience I had. I won't talk about the organization or anything, though, let's leave it at once upon a time. I did a pull request, and I was criticized for writing comments in an HTML file. I was told in no uncertain terms that you don't comment HTML files, and if I did not remove them, my pull request would be difficult to be approved. I was using Maven. I had a pom.xml file. I put comments in XML files. They might have looked the other way for HTML, but there was no way they were going to accept comments in the POM file. Now, I gave in. I removed all the comments they didn't like, and I did that because I was contributing to someone else's sandbox. And so it was, their toy box, their toys, they make the rules. Looking back on it, I regret giving in. And going forward, when I contribute to this project again, I think this time around I'm going to stand my ground. Here's another one. I am particularly annoying to Brian Getz from Oracle whenever I bring this up. And actually, I take it a more extreme. I really have no idea why we even have a main. I'm going to pause for a moment. Somebody's just asked me about examples of comments in my POM file. If we have some time at the end, I do have some code to show you that adheres to the rules that I'm talking about. So I'll get this and make this available to you. Okay, back to main. I think of programs as dominoes. You can see from this cute illustration, right, where you line dominoes up, you push them over, and we've probably all seen those, 1 million dominoes that spell out something amazing. Well, maybe our code isn't that complex, but that is the role of main. It's that first, that little finger push that starts things going. I tend to think of the main method as the program's CEO, Chief Executive Officers. Chief Executive Officers delegate work to staff. Staff, by the way, are non-static methods. Main methods should not be, as it says, they're rolling up their sleeves, getting down on the shop floor and working alongside or making day-to-day or micromanaging. No. Main is a necessary evil, so the JVM knows where our program begins. And so that's all main should do. As I like to say, it should never be more than 2 or 3 lines. And I will say something strong here. If you've got more than 2 or 3 lines in your main, you're doing it wrong. Let's look at an example. This is what I describe to my students as, based on the latest version of the JVM, the perfect main method. So, public, class, well, there's moose. Remember, I warned you, I'm fond of the word moose, if I'm not using my favorite number, Bob. Look at the main. There are only 2 lines. The first line instantiates whatever object needs to be instantiated. In this particular case, it is the same object main is in. It could just as easily be a class or an object from another file. In some cases, the main app file may just consist of a static main and then immediately pass control to that object. That's the role of perform. It's a term I use because it generally puts an image in my students' minds or anybody else. Something's going to happen here. This is where we start the work. Somebody was asking me the other day, what about languages like C? So there's no objects or anything else. All methods are equal. Main is just special because the runtime will find it. Well, even in C, I took the same approach in my teaching. The C main routine or the C++ main routine just is that first push on the dominoes. Naming things. If the closest to any kind of art form would be, I'd say, identifier naming in any language, but I'm going to blame somebody for our poor naming habits, and I'm going to blame mathematicians. Let me be clear, we wouldn't be here if not for mathematicians because everything we do is underlined by it. But it doesn't mean they've been doing it right. If I use, and I picked this as a silly example, the Pythagoras theorem for calculating the hypotenuse of a right-angled triangle. So there we go. We all saw it. Well, sometimes you see it c squared equals a squared plus b squared, or as I've written it, a squared plus b squared equals c squared. Great. And if we've got a book and there's a picture of a triangle, well, I grew up believing that all triangles had a side named A and another side named B. They had a hypotenuse named C. And then I discovered that there were A's, B's, and C's in other geometric patterns. Couldn't they have just called them by what they were? Side 1 squared plus side 2 squared equals hypotenuse squared? Well, maybe this is my problem, right? We could have all done better in math if we didn't get all that English and Greek letter confusion. Who knows? The bottom line is proper names. If you want to hear me, belittle a student, just have them show me code where they have a single letter variable. I am polite when I do it, and I do make sure they laugh when I'm finished, and then they'll never do it again. So I've always been fond of the Java naming conventions. We all know them. If it's a method or a variable, the first character is lowercase. We do it in camel case. We generally have variables as nouns, methods as verbs, classes, again, well-known stuff. There's my moose farm. Again, generally classes are nouns. There are more exceptions here. We move on to constants. We do that all in uppercase. And of course, we do want multi-word names. I was thinking about my very first personal computer, which was an Apple II. And in learning to code that in BASIC, before I discovered assembly language was much cooler, when I used to code in BASIC, you purposely named every variable A, B, C, and when you ran out of 26, you started doubling the characters because every variable took up the size of its name in the executable. So you needed to keep the name small. That's not the case. You know, as I tell my students, and I usually get a laugh out of this, you do not want to have a program dealing with selling boats in which you had a variable named sales of boats and you decided to use the abbreviation, well, you think of it, sales of boats. One last thing I want to mention about naming, and that was Hungarian notation. This was an invention. This came to us from Microsoft, one of their developers. And when I first saw it, I went, wait a minute, this might work. This might make sense for my students, right? The idea that a prefix would define the type. So now it didn't matter where in your code you saw a particular variable, you'd know exactly what their type is. And I understand this is still the main technique in the world of C#. What I discovered was, working with my students, I had some problems. Believe it or not, at one time the letter D meant integer. Then the letter N meant integer. And when I looked, it appears that they finally allowed I to be integer. That was an issue, changes. The real problem, though, revolved around refactoring. Right? If I have a program and I decide a particular type should be int to long, in most cases I can just change the declaration and maybe adjust a few places, if at all. If I'm using Hungarian notation, I've got to make sure that I properly rename every instance, every location that variable exists. So I'm not speaking against Hungarian notation. I'm just saying if that is your methodology of choice, be vigilant when you're using this convention. Testing. So my first remark here, of course, is quite insulting. If you aren't using a testing framework, then consider looking for another job. I tell my students that when it comes time for me to evaluate their code, the first thing I'll look at is their test code. Are they sufficiently testing the code they've written? Have they covered the range of possibilities? And if I believe that their testing is appropriate, only then will I look at their source code. Some people like to put tests in main. It's kind of easy, instantiate the object and run some tests there. Don't. This can be particularly troublesome when we remember that we can have multiple mains in Java, and all we need to do is leave the inappropriate one, the wrong one in place, and who knows what'll happen. As it says, see best practice is 5, which was keep the main down to 2 lines. Not sure what to test? Pretty easy. Well, first of all, if it's a public method, it should be tested. If it's a public method that changes the state of an object, it probably needs a lot of testing, parameterized testing. Last point there, when I say when the boss asks you if the code is working, your answer should always be, once the code passes the tests, I'll be able to tell you. Best practice number 8, software patterns. I'm fond of them. Software patterns give me guidance. They give me a starting point so that I'm not flailing, just trying different things, unsure of what's the best way to go. Therefore, it's important that you familiarize yourself with them, what their goal is, what their purpose is. Learn to recognize patterns in code you've written before, code you're writing now, in other people's code. And avoid the two most evil software patterns. The first is the kitchen sink pattern. And I should have some time to show you an example of that. This is where, as the code evolves, if things aren't working, the solution is always adding more code. No, please don't. And then, of course, there's the stream of consciousness pattern. This is where we write code as we think of things, as they come to mind. Ooh, I need a little input. Here's a little input. Ooh, I need a little processing. Here's a little processing. Should I break this up? No. This is the way I'm thinking. This is the way it should be. No. I think if we get to see some of my examples, you'll see what I mean by stream of consciousness. We're almost done here. Best practice number 9, the operating system is irrelevant. If you're coding in Java, you're coding for the virtual machine. You're not coding for Windows, for a Mac, or for a Linux box. And if that is your goal, to write code that can only run in one of those environments, well, then Java may not be your best choice. In addition, as you've written the code, even if you know, well, I'm only going to run this on a Linux box, or I'm only going to run it on a Windows box. Well, without Mac servers, I don't know what we run on a Mac anymore. But regardless of which environment, consider doing your testing on at least one other OS. Be certain that your program will work reliably. I'm going to tell you that I do all of my development. My students do all their development. All our Java application servers at Dawson College are all Windows machines. There's a smattering of students who come to class with Macs, and the code just works in their Mac the same way it works in the Windows boxes. Don't code for the OS. And then finally, best practice number 10, it says IDE and build system. It's really the build system is key here. First of all, IDEs. There was a time when different shops, and I'm sure there are still many today, that declare themselves as a shop for a specific IDE. We're an Eclipse shop. We're an IntelliJ shop, a NetBeans shop. There's probably a VI shop out there somewhere, but let's not talk about them. The fact is, IDEs, in my opinion, are very personal. That you use the IDE that you perceive, that you feel makes you the most productive. That's why you choose what you do. But there's a problem here. A project created in Eclipse can't be opened in other IDEs unless it's converted. And not every IDE has a converter to the other IDE. So now we've got a problem. If anything, you almost have to tell all your employees, all the developers, we all have to use Eclipse so we can all share code. And that's related to the IDE's build system, how it manages libraries and code internally. And most of the major IDEs have their own custom, we invented it build system. It's better than anything else. And it may well be. But it locks in the developers to your particular IDE. The solution here is use an industry standard build system. Maven is the most widely used. Gradle continues to gain in popularity. Heck, in a pinch, use Ant. And for any other old timers out there, remember that Ant is Java's version of C make. Over the long term of any project, a lot of developers are going to be working on it. And building a project in such a way that it can only be used in a given IDE is a mistake. It will get in the way. If we use Maven, and I'll be honest with you, as much of a fan of NetBeans as I am, I do tell my students who have all used Eclipse and IntelliJ by the time they reach me, that if they would like to continue using Eclipse or IntelliJ, you'll see all my examples in Maven, I'm not going to care, because as it's Maven based, your code will open and execute in any environment. So what I say to people is, don't require a specific IDE, require a specific build system. Ooh, we have some bonus practices I want to talk about. First of all, there's consistency. We meet with companies every year at Dawson, the potential internship companies, even companies that employ our students. And our employment rate at Dawson College is, once we factor out the students who've gone on to university, we look at near 100%. Montreal is a very strong market. So these companies come in, the college buys them a free supper, and we chat. And one question I always ask is, does your organization have a manual of practices? That when our students come to work for you, you're going to have a book that says we're using Hungarian notation, or we're using this particular tool. And the most common response is no. There are no standards in our company. We hire programmers to know these things. We let the individual teams figure it out. Well, that scares me. You've got 5 different key teams using 5 different methodologies. All the people that I meet care about is make it work. So I encourage you, if you work at a company that doesn't have a manual of best practices, write it for them. Share it with the people around you. This will ensure a better working of a team who all follow the same principles, some of the same techniques. Time for a double bonus. Static. If you follow me on Twitter, I mentioned something recently. In my courses, students are forbidden from using the static keyword without first getting my approval. And to get my approval, they have to demonstrate why static makes more sense than an instantiated object and its methods. I can tell you last year, in the fall semester, where my students wrote a Twitter client, of the 42 students I had, there was one request to use static that I accepted, and I turned down every other request. Why do I do that? Well, maybe it's because of what I understand static to be. When we moved from C to C++, static variables were in place, as I understood them, to avoid the overhead of object-oriented programming. When I learned C++, we were still in the era of the Pentium, and we thought, well, maybe you had 1 or 2 megabytes of RAM. Well, that was amazing. Not 1 or 2 megabytes, excuse me. 640 was what Bill Gates thought we'd all need, but still far less RAM that we see today. But static was a way to deal with that, right? We could do certain things just that many cycles faster if we did it in static. So Java, which is derived from C++, it brings static along into the virtual machine, but we've forgotten that C++ and Java are not the same. C++ is what I call a bare metal language. It's running directly on the operating system. There's nothing between your code and the OS. Of course, Java has that amazing JVM in between, a JVM that optimizes, that improves what we write upon. So in the end, what I tell my students are there are 4 reasons for static. And if what you ask me isn't one of these, I'm not letting you get away with it. So here we go. The first, what I call methods of a general nature. And I use the example here, math.pow, or any of the math libraries. In all of these cases, if I see a call to math.pow, gives me no sense of what the purpose of the program is. I need a very specific task, a task that can be coded typically in a single method, a method that takes input and output. There are no instance variables. It does a specific job that's needed, but doesn't express the goal. The math library is an example of that. And I should mention, although it's one down, there's a relationship there to the concept of functional programming as well. Next, variables used as messengers. And I saw a message go by not long ago about singletons. I didn't finish reading it before it disappeared, but a singleton is a perfect example of using a static variable as a messenger. We have an instance already. Therefore, if I try and create an instance again, I want to return the existing instance. The static variable does that. Functional programming. This is the new up-and-comer. It's exciting. Not sure if I'm crazy about the need for static here, but that's one of its rules. And then finally, shared constants. I always write constants as usually public or, public, final, static, and off we go. So why do I see static being used improperly? Well, if you put code in main and you want main to interact with a class variable, with an instance variable, you can't. It has to be a class variable. It has to be static. Not permitted, at least for my students. If I'm using static so that I can misuse main, I'm doing it wrong. Ooh, and just before I decided I was finished while I was doing my rehearsals this afternoon, I came up with the super double bonus. This is the last one, by the way. We live on a planet with billions of people who are, most of them, shall we say, at least in the West, sitting at home most of the time. So we've got billions of people out there, and they all desperately want to buy stuff. And if you have good stuff, they're going to want to buy your stuff. So then I did a little Googling. Remember, I'm a programmer. That's what we're all supposed to be good at. I came across the fact that there's approximately 7,500 languages still in use on the planet. 6,500 are described as in regular use. But the reality is there's... Somebody asked me if COBOL is one of the 7,500 languages. Actually not. It would be kind of strange to talk COBOL to someone. The fact is that there are about 200 primary languages. And I was surprised to discover that English was at the top of that list. I would have guessed Chinese, but it doesn't matter. The fact is that we have available to us internationalization, a way in which... Oh, I just heard somebody in the background. Nope. Okay. Always, I see internationalization. Whoops, I apologize. Somebody's pointed out that I should have said Mandarin and not Chinese as the name of the language. I apologize. Internationalization is built into Java. We want to apply it to our user interface. I live here in Montreal, and you should know that Canada has 2 official languages, English and French. It's like goes without saying that every programmer in Canada uses internationalization. You want to get a government contract? Your software better work in English and French. And certainly, we see companies, whether it's Facebook, whether it's Amazon, they certainly understand the value of using or having available different languages. We don't want to have 30 copies of the same user interface code, the difference being one is in Italian and one is in German. Internationalization says we don't have to code that way. I have to admit something evil I do, and especially as I'm talking to an American group, maybe I shouldn't admit it, but I do kind of have a little fun when I go down to Code One in San Francisco and I'm sitting at a bar, sitting at a session, talking to a programmer, and when they reveal to me that they work somewhere in the beautiful country of the US, I always say to them, so, you guys use internationalization? Ask yourself that question now. So, before we look at some code briefly, I have some last advice that I'd like to give you. Something to become that best practice for you. It begins with the idea that you want to write code as if it will be running till the end of time. Now, again, we can say, well, there are limits. My employer only wants me to spend so much time. I certainly understand that. You certainly cannot go back to your employer and say, look, I need another $500,000 and another 6 months to finish this, even though that'll be $500,000 in 6 months more than what you're charging for it. So we always have to find balance. But it still doesn't hurt to think that your code is going to run forever. Also, consider that once you write your code, you've refactored it, and everything's working well, you're never going to work on it again. You're never going to see it again. Someone else is going to be responsible for it. And then finally, consider this possibility, that the next job you go out for, the next person who may hire you, may have been someone who you worked with, who had for a certain amount of time the job of looking after your code. So, we've talked a little bit about, my points and best practices. I'm looking at time. I could probably squeeze 5 more minutes out of Mary. Let's just look at some samples here. So give me a moment.
Yeah, you can.
So, I ask my students to write a program, here we go, called Passline. If you've ever watched any movie where the characters are playing a dice game in a casino, I'm acting like you don't know anything about gambling. Of course, you probably know more about it than I do. But Passline is typically the kind of dice game that shows up in the movie, where, people roll the dice, and they seem to roll it multiple times. So it's a simple game. You can read the rules here. I won't bother to read them out to you. If anyone would like a copy of this assignment, send me a message. I'll get it to you. I don't publish it because I use it in my classes, but I'd be more than happy to send anyone a copy of this. So let's take a look at how a student solved it and how I would have expected it to be solved. So let me open up my little project here of bad pass line, right? So we're looking at a game. Let's pick bad pass line number 1 and let's run it. So here's the scenario. I have given this assignment to 43 students. They have 24 hours to complete it and return it to me. I don't really care what the UI is. In this case, the UI is command line. The course they're taking with me is about JavaFX. This is the course where they move from basic understanding of programming to crafting UIs and developing final projects. So, how much money are you playing with? So I'd say $100. Okay, how much would you like to bet? $10. And whoops, I rolled a 3 and lost right away. Yes, I want to play again. I think I'll type in my favorite number, which is Bob, by the way. Smart program. So, program seems to work. They're submitting this before they knew how to test things, so I'm not expecting unit testing. And then I look at the source code. And this is what I see. Oh, there's Maine. Well, I suspect that the student heard a rumor that I like a lot of comments, because they've pretty much commented almost every single line. That's a little scary. There's the obvious. But have you noticed something else? There's only one method. It's just main. This is absolutely a stream of consciousness program that the student, as they wrote it, as they read, okay, what does the program have to do? They simply put it out. Now, that's not necessarily bad unless, of course, you put all the code into a single method. Somebody asked me the other day, give me a good reason why you should hate main. And the answer was unit testing. But that's another story. Think about how you'd unit test main. I'm sure somebody knows how, but it just doesn't make any sense to me. So, can you guess what I gave this student? Probably not, because I'm a really evil teacher. On the first, doesn't count here for your final grade assignment, this student got a 0. This student submitted a program that worked perfectly, and yet got a 0 on it because they coded it unprofessionally. I think, as I said, 42 students, well, I was talking about the student who asked for static. Of the 42 students who submitted this assignment, only 2 got a grade better than 0. One of them got a passing grade, one of them got a failing grade. In the time that I'm with my students, I'm talking about best practices. I'm talking about, and we'll just look at the packet structure of what I then present them. Here's the game. Divided up into different categories of operation. The presentation layer, the business layer, the working layer, data layer. I even have state. This is where I gather up all those global constants. At the end of the year, the students that I turn out, mainly because they want good marks, but I think also because they recognize that it's making them better programmers, have learned to apply the patterns, learn to apply the best practices I've just presented, and find themselves doing really well in the job market. So there you go. I'm just going to stop sharing this if I can figure out how. Sure, there's some way. Here we go. Share.
Yeah, it's in the bottom there.
No, I see it on the top on mine. So I have something called share. People are viewing your screen.
You are sharing. Yeah, you're right. Yeah,
so how do I stop it from sharing?
Okay, there should be, like on the left side, if you're sharing, it should be like an orange kind of menu up top.
See something orange?
Stop. Orange or red or something. But.
There it is. I'm sorry. This is the first time using WebEx, so I've got it wrong. So there we go. Thank you all for listening to me.
Thank you.
I hope you've learned a few things. I'll stick around and chat with anybody who has any questions. You can always find me on Twitter at OmniProf. I'm interested in talking with anyone. Thank you.
Yeah, thank you, Ken. Yes, and anyone, if you have questions, please feel free to turn on your video, and if you want to ask your question, then just speak. So feel free to turn on your camera and your audio to talk, or you can type it in the chat window as well. So either way, did we already go through some of the questions, or?
Well, I certainly, as I noticed some of them pop up, I tried to answer them. Somebody asked me, did I try a negative number? And so I actually got interviewed on a podcast over this, and I've written about it. It's what I call the Beethoven Test. So here's what you do. You're confronted with a program, doesn't matter if it's a GUI, doesn't matter if it's a command line, and you put your fingers over the keyboard. I know you can't see my fingers here. And you hum a little Beethoven while you smash at the keys. Something like da-da-da-da. Just hitting keys randomly, and then hit return. In one of my examples, I have a student who seems to have a slightly better approach to their coding, except it crashes every time I type Bob, because they never bothered to test their code suitably. That was another 0.
Okay. All right. So we have a question from Matt. Matt says, "I'm still curious about your Maven comments. If you
yes.
So
if you don't mind, I will share again quickly here. Let's see if I can find that. There we go. Share screen 1. Good. So let's visit my what I call the parent POM. Can you hear me? Can you see me? Yep. Okay. Here we go. This is what a commented POM looks like, right? And you can find this file, desktop project dependencies, over on GitLab, not GitHub, under OmniProf. Now, some of the comments here are, again, I'm a teacher. I want to make sure the students understand what things are for. I describe the purpose of the different dependencies, what they're used for, indicating where my goals are, and so on. And yet, I had to remove all of these comments to get my pull request accepted. So this is what I mean by comments. You can't have too many comments. I don't understand. And I've gotten into arguments about people who either don't believe comments should exist or they should be minimal. So I'm reading another one. So they seem to me very redundant. Well, it all comes down to what your experience is. So I'm dealing with students who are just starting out, that there is nothing redundant here, right? Like understanding, for instance, we use this new JavaFX Maven plugin. And I thought it was worth pointing out that it also works with non-FX programs. In other words, we're using the FX runner to actually execute my command line program. So that's where I see comments are significant. Yes, you can argue that after X number of years of writing this over and over again, well, of course you know what this is. There's no need to point out that this is for JUnit. But not everybody begins their career with all the experience that you have.
So I agree. If this is the teaching tool, then yes, you can put comments on every line to let them know what it means. But I thought that you had some professional Maven POM comments, and you were criticized for that. That was my understanding. But still, even for the teaching purposes, if you scroll up, please, just scroll up.
Oops, let me get up here. Yeah.
Yeah, all the way up, right? Yes. So I'm kind of leaning towards self-describing comments, meaning that your code, as you mentioned, I fully agree with giving a good name variables or methods or class names that describe the purpose should be enough. But sometimes you need to describe the algorithm, all other things. So use the comments when they really are beneficial, right? In your case, I think they are redundant even for somebody who starts, because packaging to be a parent POM for other projects. Packaging is a good name already for this, right? Name of the project in the repository. Name, I think, already should indicate what it means. So I would remove those if I were you. Obviously, there's nothing wrong, right? It's a kind of preference. I see your point, but personally, I wouldn't use those comments at those points. And you have dependencies, right? dependency has a name of the group ID, artifact, and version. Why do you have to specify binding for log4j? Isn't it descriptive, for that JUnit testing dependency? I think whoever knows the Jupyter should know that this is, JUnit 5. But again, it doesn't hurt. It's fine. Okay, I got it. But to me, they are redundant, because I think the Maven has good naming conventions to self-describe those XML nodes. But just
thank you for your comments.
That's just personal.
No. That's, and I think that's important. And again, it comes down to, something I said about being consistent, right? If you, using names properly. And you're right. When I look at that comment and I read it now, where I go packaging to be a parent POM for other projects, yeah, that's a mistake. I should be explaining what a parent POM is right here, so that my students know why they have two POM files.
Agree. That would be probably better. Right. Agree.
Yeah.
Yes, exactly.
Yep.
You should explain that. Absolutely. Point well taken. Yeah.
Thank you that's why I love giving presentations. I get to learn stuff too.
That's right. Yeah. Well, thanks for that question, Matt. And there's also a question from Aditya, right? Did I say it right? Okay. Before working on the code logic to solve a problem, should we think on the logic to write the unit test cases first? If yes, would you call such a coding practice more professional? Then Andy said that's called test-driven development. Yeah. So if you'd like to comment on that, Ken.
So TDD, it's important. I have to admit it confuses me a lot. My mother was hearing impaired, and we used to communicate over the phone with a device called a TDD, teletype device for the deaf. So every time I see it, I have to think for a minute. Are they talking about my mother again? No, they're talking about test-driven development. My feeling about test-driven development is it takes some experience as a developer to be able to do TDD well. Right? I'm dealing with students who, are still sitting there staring at a for loop every now and then. Strange question. I'm sitting there with a for loop every now and then, trying to figure out how it works. So until you are really comfortable coding, until you have gained the experience in planning your code, I don't think you start as a developer with TDD. I think, and it's what I tell my students, and of course, unfortunately, they won't let me put or leave their cameras open so I can watch them coding 24/7, is I tell them every time you write a public method, you immediately write its unit test. That's the approach that I encourage. And I believe over time, the skill and experience will allow you to evolve into test-driven development.
Great. Okay. So I got scroll up to, I don't know if you have already answered this one. Which I don't believe so. Juan Manuel Gonzalez. Regarding software patterns, what happens when trying to adopt some of them as good practices on programming language and let's go down, and which are not using frameworks to separate layers like MVC to make it testable to unit test? What do you think about using patterns on Go language, for example?
There's no straightforward answer here, right? We certainly see more and more patterns that, not patterns, more and more frameworks that are becoming more and more like black boxes. We don't really know how they're patterned. And that poses a potential problem in determining what we want to do. I think, we want to look at a problem and say, okay, can I solve this problem with basic Java SE? Do I need a framework to provide assistance? And do I use the framework as a black box? Do I make it part of the particular pattern that I'm using? Right? We always think of things like MVC, But then, the factory pattern is probably, in my opinion, one of the most widely used. Doesn't need any frameworks. So there's no hard and fast answer to this. And I hate these kind of answers, because the answer is, it depends.
I agree. So, cool. I'm still kind of looking through to make sure. I think it looks like you already, like some of these specific questions you have already addressed them. So, now,
well, again, you can.
Oh,
I have another one, if you don't mind.
Oh, please go ahead.
Please.
Yeah, following the Maven, I'm just curious because you mentioned that, and I agree with that statement, that IDE is not the crucial tool. We should not rely on built-in build. Absolutely agree, because that couples you with the specific, and I've seen that, and it could be very annoying, frustrating. So you should use a built-in tool, actually project management tool, because that's what the Maven is. It's not only build, but anyway, or Gradle, etc. So I'm wondering, how do you solve the problem with different versions of the Maven that your students might have, or at work, right? You join the company, and now the question is, yeah, go ahead. You need to install Maven first before you even start, building anything. Oh, this program has a version of Maven 3.0. Another one has 3.5. Which one should I use? So this is on the topic that you mentioned, and I really liked it because, to me, consistency is very important. So how do you solve the consistency for Maven distribution across the team, across the project?
So in this particular case, and for me at least, my team is my students, and that's where, for instance, I find having a parent POM, or I guess it's like a superclass POM, right? This is what I give the students. So they receive from me what effectively becomes the company standard for versions, and that if a student wants to and I tell them this, I'm giving you version numbers. It is not your responsibility to discover, I'm using plugin 1.1, and something I always liked about NetBeans is it'll tell me that there are newer versions. I make it clear to my students that you don't change the version, that this is something, imagine you're in a company, there's a team, and one of you notices, oh, wait a minute, there's a 1.1, a 1.2, unaware of changes that may affect other people. So it comes back to, as you pointed out, this idea of consistency, right? That in any team, I would assume that one member of the team is responsible for that master or parent POM, and that nobody else changes version numbers without that individual's approval.
Right. I'm not sure if I made myself clear, but actually I was looking into something as an answer, Maven Wrapper. It's quite an elegant solution, and that solves the problem of having all the members of the team, or you can use this across the company, that will take care of downloading the Maven version before you even start using it. So no worries to use different versions, because you will get it if you don't have it, right? And you can specify it, and let's say 3.5, put it into the repository source code. You just get it from the Git. You type Maven. There's a slight of different command. Instead of MVN, you have to type MVN W, and then it will check. Do I even have the Maven to begin with, right? If I don't, then it will get the version that is approved, and you can specify only in one place. So you don't need to worry about POMs, because POMs is kind of implementation. I was curious about the same version of Maven for all the members of the team. And if you didn't hear about it, take a look at it. I recently used it at the company. Maven Wrapper is pretty cool solution for that. It will be
I'll make a note of it.
Yeah. So
I tell my students that we're working with an environment. You cannot change your environment in the middle of a project. You can't start changing the version numbers of your libraries. And, again, this idea of consistency. And
they wouldn't change it because the wrapper will exactly download the version that they're supposed to have.
Okay, I will definitely follow
Now
up.
we have to do some tweaking, but they plan to release Maven 3.7 that will have built-in wrapper, so we don't have to do any additionals. But we need to wait; it's still in beta. So, but before that, you need to just download that kind of wrapper from the GitHub. But I love it because I was finding myself, working on 3 point something. Another one had a different. Another had the latest one, and sometimes we had the build problems, right? And that's inconsistent. And the developer claimed, well, with my version it does work, with mine doesn't, right? And our Jenkins uses different versions, so I stick to what Jenkins uses, right? But still, again, this is unmaintainable. That should not happen, and it does happen. But Maven Wrapper will solve that problem for you.
Yeah, no, I agree. And I think consistency is one of the most difficult things to practice.
I agree.
So,
yeah.
And Ken, question too, curious to see, because you worked in the industry and then you went into teaching, what kind of things you feel that you like better, as a teacher in an academic setting, or something that you don't miss in the industry. So,
well, the thing about industry, and I have to admit, is I like to describe my work environment. I work in the Magic Kingdom, right? I work in a fantasy land, and let me explain to you why. When I described the school I work at, I described it as an atmosphere akin to a university, and it is. I don't chase after students like high school teachers or anything else, but I am considered a professional teacher. I'm not a researcher. I'm not required to do any research. Instead, I've become involved with the wider Java community. I'm talking to you guys. This is, my replacement for what might be research in a traditional setting. But I have found that, working with students, first of all, I'm still trying to understand why my students look the same age every year, and I keep getting older. So I'm trying to understand that. There's something to do with physics. I'm working on it. I hope to have an answer soon. But I just love taking students, and again, I'm in this third year, so I take students who, they feel comfortable, they understand a loop, a switch, they understand types, but they've been so focused on just getting the right answer in the first 2 years of the program that I have this amazing opportunity to mold them. And I'm sure sometimes I get it wrong. Usually I get it right. And, I don't have to worry what the next assignment will be. I jokingly tell people who I interview for teaching at Dawson College, one of the questions, and I do this at the very end so they don't feel too intimidated, I always ask them what the 3 reasons are for becoming a teacher. Any of you aware of it? Oh, it's an easy answer. June, July, and August.
oh,
I'm just taking it easy right now.
yeah.
But it gives me a chance to recharge. I'm someone who just is working constantly. But it is a lifestyle. I probably make less than half of what most of you make, right? But that's okay, right? The cost of living is less in Canada. My wife's a professional as well. This is actually going to be my last year in the classroom. I'm going to retire from teaching this year. That was literally a plan I made 30 years ago when I started this. I knew exactly when I was going to leave, and I see no reason not to do that. I'll continue to be involved. I hope, if I can come up with something good, I'll speak to you again tomorrow, or speak to you again here. I'm speaking tomorrow at the International Day run out of Brazil. I'm giving this and a session on Java and education. It is a lifestyle, a way. I've got brought up kids. I have grandkids. I don't think I could have found, or I would like to say I planned where I would actually be doing, but no, I've stumbled into everything I've done, and I think I stumbled into the right bushes, I guess.
Very cool. That's great. Yeah, it's a good perspective too. Yeah, being a teacher, and that also keeps you always like learning too, and like with your students and everything. So I've often
Exactly.
find when you're teaching, you're actually learning more too as you're teaching. So that's really nice. So yeah.
Oh yeah, no, I learned something today, so made it all worthwhile.
That's great. Yeah, thank you. Yeah. So wonderful. Yeah, thank you. Thanks again.